We're at Hardware.io 2026 in Santa Clara, and we're here with Will Eatherton, SVP of Engineering at Cisco. Welcome.
Thank you. Nice to meet you, Camille.
So you were just doing a fireside chat, and one thing I found interesting is what you're worrying about right now. So one of the things you mentioned is attackers look different now. Describe it's no longer niche, right?
So traditionally, to some degree, like in networking, we try to do a good job, but the expertise, you might have a software focused attacker who's going to come in and be working on a routing protocol tweak, or you might have someone else who there is maybe an interface topic on a management interface, but it's fairly disparate skill sets. And to some degree, there's obscurity to it. I think one of the topics I was hitting in the fireside chat is that we are, and it's still early, but we are starting to see in our experiments that when we take a box and we do, some basic pen testing through an LLM, which again does not substitute for humans, but when we just are doing some experiments, it can now bring together expertise across firmware, system level design, knowing what those components are that went into the board, and then coming up and, finding a possible vulnerability is one thing, but coming up with a proposed exploit of here is step by step, let's do a design like this and put it on an FPGA board that you're going to interface. Here's some embedded software that you're going to put on that. And here would be the threat model for which it would be a risk. The ability, evolving ability, everyone talks about that in software, but I think starting to see that kind of thing it worries me. It worries me because, obscurity is no longer something you can hide behind.
Right.
And I'm saying we hid behind that at Cisco, but I think you didn't necessarily get the right skill sets combined together before.
Right. Okay. So software and hardware used to be a little bit more siloed, and now that they're coming together and layer on top of that the LLM that can look at it from all angles, and then actually just run executions. I mean, you're having
So we've done that on the software side where, and again, without getting into specific vulnerabilities, the last 6 months, we've seen a major, everyone talks about AI for software development. And certainly we've seen examples where, you go from IDE being able to do a tab complete to some of the and I don't want to say vibe coding, but agentic coding. And we have done some experiments where we take a couple 100,000 lines of software code that was in C that was written 15 years ago. And then we refactor that into a Rust-based, 100,000 lines of code. Some of those, again, I'll classify those more as experiments, but it is interesting how good it can be at that. So you take those kinds of things and now you bring that into the world of security and testing. And some of the things that we've done at Cisco with Harness is the ability to put together, take software, take maybe some of the source code, and then you have a box in the lab and come up with, essentially a assembly line, an automated assembly line where it will come up with a proposed vulnerability. It will create a configuration. It'll put that in the box. It'll come up with test generation traffic to send into the box. It might have some higher level software protocol interfacing, VGP or something for that. Put all that together. It runs the test, and then it will have a test result that says, it succeeded, it failed. Maybe it will try a few more things. That kind of automation is very scary because, we've seen these start to churn out, things where you can go, one human might have spent, days coming up with a really creative. Now you could be talking about hundreds.
But not only that, but we're talking about, when you're talking about LLMs, you're talking about general purpose that's able to do these very specific architected attacks. And so what I'm wondering is, do you expect domain-specific context or domain-specific development within the LLMs to really be even more focused and targeted, like in the next 6 months?
So I think certainly in software, the models themselves have been trained where they have exposure to, common frameworks and packages across Python and JavaScript, even C, C+, they've gotten better at in the last 6 to 9 months, certainly Rust, Golang, and so on. So the programming languages, the common frameworks and libraries, open source libraries that commonly would get leveraged into larger, more complex software. So that is well known, and that makes it much easier for it to extrapolate what to do in the software world. I think in the hardware world, it is less still because the kinds of proprietary knowledge that comes into it, the scope of the, whether you're talking about a design, you're talking about a schematic, whether you're talking about, Verilog, even though it does fairly well with Verilog for chip design, it still will have orders of magnitude less sample set than it will have on any of the mainstream programs. So I think that what I think will happen in the next 6 to 9 months isn't necessarily that the LLMs will suddenly be exposed to large amounts more of data there. But and this is some of the experience we're doing, being careful about it's all about the context that you're feeding into the LLM. So being able to pull the right, here is a design, and here is the being able to have it iterate and pull the right code that it wants out of the firmware library, and cross-reference that with the FPGA design, and cross-reference that with, a Jelly Bean a power controller component, and then put together a proposed vulnerability. The ability for it to pull together that context post the model generation, I think that's and really that is what and again, not to get too far into the AI topic, it's not just about the baked in knowledge, but ability for these models to get better at that reasoning and the multi-step, where it can then pull those contexts together and then use that in order to come up with a plan, kind of thing.
And right now we're almost at the precipice of open source hardware.
Yes.
Are we going to see kind of a rollback on that, and companies are going to be pulling that back just for security reasons?
I don't think so. I will, on software, I'll say, there's always many risks with software, but having visible software has been a good thing. We've been very excited, like Sonic is an open source network operating system that Microsoft and Google have been involved with. We've been involved with years in contributing to that, even though we also sell like proprietary software. I think those things are good things for the industry, and it hasn't been a major rollback. In fact, I would say there's cases when we're going through software design where we'll look at things and, maybe we did an SSL library 15, 20 years ago internal, and then we've been maintaining it, but we're looking, it's what's the value of maintaining that? What's the risk of maintaining that? And then these tools are now saying, hey, maybe it's time to drop that internal library and use an open source library and really start working on adding some features and upstreaming it on that rather than maintaining the internal. So I think, the whole, if you think of everything as an attack surface, every proprietary component you do, whether it's software or hardware, becomes a potential new attack surface. And when you do have common reuse components that are open, I think that can reduce. So I'm hoping, as an engineer, I'd like to believe that we might see, better discipline around that and more use of it. I don't know that I would see really a pullback necessarily from open source because of this, and that's the impact.
Okay. Yeah. What other kinds of what sort of trend do you think we're going to see moving forward here with hardware development?
So one of the things I was mentioning, there's a lot of things that are getting more and more complex with hardware development. So, and the big part for us is working with like the hyperscalers and these AI build outs with data centers. And so, there's been a lot of trends that are going from, the SerDes, the ASIC interfaces. It used to be you'd spend years increasing the speed of those. Now, with like NVIDIA out there improving the rate of their generations, and that having the next generation of the networking and so on, you now are going from like 100 gig SerDes to 200 gig to 400 gig in 2 years, 3 years kinds of time frame. So that's become just this pressure to increase these things. We're seeing things like liquid cooling and co-packaged optics, where you actually would have the chip, and then instead of having all of the traces and the SerDes running through your PCB, which there's a whole bunch of signal integrity work and all that, instead of having that run into a pluggable interface that would then have like a fiber optic, now you might have a fiber optic that actually runs to the top of your chip. In some of these cases, it could actually simplify some hardware because maybe you don't have as many of the Jelly Bean components and all that, but but that would make the components, these silicon chips and so on, more and more. And I think what we're seeing with the multi-chip, with the photonics, with memory being incorporated, that these silicon devices, which maybe that's why we've seen the market shoot the market cap these coming. But we're seeing that is becoming trickier and trickier. There's maybe smaller numbers of companies that are really doing that.
Perhaps complexity makes it less inherently less secure.
So that's pulled into that and a little bit out of the system in some regards. But that does mean then, from a security standpoint, that as a broader industry, we are maybe more reliant on those kind of silicon components. And it does mean that and for folks here at hardwear.io, really, how do we up the level of attack on silicon type things rather than, the broader and again, full system is still very important, but the silicon side is the center of a lot of the attack value these days.
And you're also going to have to increase the pace of rolling out updates.
Yes. And so we've seen that we what might have been, we would typically And some of our like network OSs, we would come out like twice a year. Customers would maybe upgrade like the financials, maybe once or one every year or two. There were customers that might be 10 years, or I've actually at spots seen customers that had never, since they bought the box, never upgraded the software. And it's like your head just wants to explode from the security vulnerability of that kind of thing. But what we're seeing now with this new rate, and it is going to be in significant. People talk about Mythos Glasswing. I'm going to broaden it and just say that the models we're seeing is that software updates, we're going to be now putting them out quarterly, where we're going to bunch up every quarter, and we are going to be advising more strongly than ever that it is good to take each one of these quarterly updates. And I think that is going to, we're in, you can call it critical infrastructure. I think this is going to have a ripple, whether it is other enterprise software, whether it's, SCADA and utilities. I think that the next year, we're at the very beginning of what does all this mean as far as the kinds of vulnerabilities that are being found. How do you get those updated quickly in the code? And then how do you get those actually deployed? And what does it mean if you're doing these software updates on a more, all those things? People have been, talking about automation of those things for years. And, it's a very mixed bag on how far folks have gotten in different industries. So, yeah.
Right.
So it's a lot of change.
That is a lot of change. So as an engineer yourself, what is the most fun item that you would recommend any engineer have in his or her lab or garage?
Well, I think one of the things that, and I was a silicon engineer.
Besides a bunch of your products.
Yeah, there we go. Silicon engineer early on. FPGAs, I have always, and I like to play with that, open source tool chains. I think everyone should have try experimenting with just doing some simple FPGA designs at least once. I think that, and interesting enough, even some of our high-end products, we will still have FPGAs in more for sometimes translation or, a glue type, but FPGAs, the ability to have this high performance, essentially silicon device that is something that you can program yourself using open toolkits. And now with AI, it is easier than ever to, even if you're not an expert and you don't understand, you're not an expert at Verilog or VHDL, being able to put together a base design and experiment with that. And I think we're going to see more folks, which again, also is a worry of mine, but now there's a lot more folks that can be doing, everything from embedded to FPGA, putting those together in, various hobby hacking devices and putting that on a management interface on one of my devices. And so I think those things is both fun and maybe a little worrisome.
I will say you have a energy of optimism around you.
Well, I'm going to say around engineering, one of the things is historically, like a lot of us work in engineering where it always feels like the good engineering is getting under prioritized. The positive around a lot of this AI aspect, which, and again, there's many downsides that potentially happen, but one positive is it's harder to hide. Like if you have not put in the effort into maintaining a good code or a good product, the business guys might typically like said, oh, the revenue is going down. Let's keep reducing the engineering on it. I think now that is going to be more visible, and I think it's going to be harder to ignore. And from a good engineer, I'd like to see products that are maintained with love to the very last day, that customer decommissions it, which sometimes for our product, we have customers on the bad side that might use products 10 years after it was no longer supported. But I'm hopeful that we're going to see more good engineering happening and that it is harder to hide behind a cost-benefit analysis.
Will Eatherton, SVP of Engineering at Cisco. Thank you very much.
It's great to meet you.
You too.
Thank you.